Today I have done my second task from the Sparks Foundation, that was prediction using unsupervised machine learning. In this I have used k-means clustering. Now first of all what I have done that I have opened my Anaconda prompt and activated my environment. In this environment I have changed the directories and went to my folder where I am doing all my tasks. Then I opened Jupyter Notebook from there. After that, I went into this window. What I have done here, these are the basics what I have written. This is my name written here in the markdown column. In the first cell, you can see I have imported the libraries NumPy, Pandas, Matplotlib, and sklearn. Sklearn here is used to import the datasets. The iris dataset that I have used here, I have imported it from the datasets from sklearn. I have used this code datasets.load iris and stored it in the variable iris. As you can see that it doesn't provide a proper data frame. You can see this is the data, consists of 4 features, and here at the end you will see the target variables which is in the array form different, and these are the target names, or you can see these are the column names: Setosa, Versicolor, and Virginica. Now what I have done here is that I have created the data frame from the data above, and I have given the column names is equal to iris dot feature names. These are the feature names, remember. So I have given the feature names, and then I am printing the data frame. Now you will say I have also printed data frame.head, which is allowing me to see the first 5 rows of the data, but I like using only the name of the data frame because it gives the first 5 rows and the last 5 rows, as well as it also tells us the shape of the data. We have 150 rows and 4 columns that are sepal length, sepal width, petal length, and petal width. Now I have used dataframe.describe to describe everything important about the data frame: count, mean, standard deviation, min, max, and the percentiles. Here I am checking for the null values. As you can see, there are no null values. I am using ilog function and just putting these values of the 4 columns from 0 to all the columns. This is the normal syntax for ilog, where these are. Here we write the rows. As we know, I want all the rows and I want all the columns from 0 to, and there are many ways you can write. You can also write here 1 0 1 2 3. That will also give you the same result. And I have printed my x. Here I am importing k-means to make the clusters. Here what in the next column what I am doing is that I am going to use the ALPO method to find the optimum number of clusters. I have first initialized a list. It is an empty list. WCSS stands for within cluster sum of squared. What is that? What does that means? It will be the sum of the squares within a cluster from the center. So what I am going to do here is that I am taking different values from 1 to 10. Remember, the 11 will not be included in the range. What I am doing is that I am initializing the, you can say, object, or making an instance, and I am giving the clusters, n clusters is equal to I, which will be are these values. And initializer I have used k means plus plus, and random state is equal to 0. K means plus plus, what does that mean? K means plus plus selects initial cluster centers for k means clustering in a smart way. What will be the smart way? They will be very far away from the clusters in the initial stages. And as we calculate the averages, they will be come into the center of these where normal data points should be, where normal centroids should be placed at the end. I am fitting the model with the data x, and now I am appending these values. K means dot inertia. What is these values? Inertia gives the distance between centroid and the other points. Here I am plotting the figure. This is the figure size with width of 14 and height of 7. I am plotting the whole list here and these are the title, x label, y label, and as you can see that why it is called the elbow method, because it forms an elbow. And what value we will be choosing from here? We will be choosing the value which will be here. Always remember to choose the value which is at the elbow point. So I have chosen 3 from here, and now I am doing the same thing. Remember I fitted the different models here in the range. Now I am only using the n clusters as 3. Now here I have used fit predict. These are my predictions. What I'm going to do now is that I am going to visualize the clusters. I am using plot.scatter for 3 clusters, as we know that there are 3 variables. Here I am providing the x variable and here is the y variable from column 0 and column 1. What are column 0s and 1s? Remember, our column 0 is sepal length and column 1 is sepal width. So I am going to plot a graph, uh, you can say sepal length versus sepal width, and this is our graph. As you can say, it is beautifully representing the clusters. You can also see that there are data points that are going in between other clusters. Now in the next column what I am going to do is that I am going to plot the centroids. I have just used an extra line of code, which is this one. I have used k means dot cluster centers and from the first column and from the from the zeroth column and from the first column of including all rows, and color I have given yellow, label is centroids, and this is the same normal code for plot for x label, y label, and this is how our final graph and final clustering looks like. Thank you so much.